Hello, Neve. Hello, you.
Hi.
Hello.
Hello, Elysium. Hello, Colby. Not sure how you snuck in, Colby. You didn't go through the waiting room. Seems like somebody manages to do that every class. I don't know how it works. Hello, Arya. Hello, Elena. Hello, Yusuf.
Hi, Mr. Bywater.
Welcome, G-Man. Hello, Averett. Hello, Lucia.
Hello, Mr. Bywater. How's your day been so far?
Pretty good. I taught physics this morning. That always makes it a good day.
That sounds fun.
Hello, Deborah. Welcome.
Hi.
Right. We're just, I think that's about it. I know Sarah said she's going to go to bed. We got you, Deborah, Arya. Oh, Sem. We're waiting on Sem and Dewa. Okay, Sem, Dewa. All right, well. Oh, and Nav.
Day was in the waiting room.
Dewa is in the waiting room now. Yes, he is. We'll just let him in. All right. So here's my thoughts for today. We do have a celebration next time. So what I'd like to do is we're going to work some problems here for the first half of class or so. And then the second half of class, I will just give you guys some time to either work or go to breakout rooms to talk about things or ask questions or whatever else needs to happen there. And I'll answer questions and help out where I can. By that time, there should be a assignment posted on the AP Classroom. I'll show it to you for those who haven't used AP Classroom before, but it should be pretty easy to see. There's just some free response questions there that are AP style free response questions. And then there's also some multiple choice questions there that are kind of AP style multiple choice questions so that you can kind of get a feel for that. Okay. Any questions before we get started? All right. In that case, here's what we're going to do. I would like for you guys to work example number 10 from the student note packet. All right. And I will post it here for those that need to see it. You can take a quick snapshot of it if you don't want to open up that file. So this is it right here about Jin Woo angry about the last quiz. So this is the question I'd like you to answer. What I'm going to do is I'm going to send you out into breakout rooms and you have access to a Jamboard. If you haven't used Jamboards, it's basically just a document that you are free to use, but you can all edit it at the same time. And so if you all have it open, you can open it up on your iPad if you prefer that, or you can open it up and have it as just a separate screen so you can be talking to your group and also working on the Jamboard. The Jamboards, have we used them in this class yet? No, okay, I couldn't remember if we'd gotten to that. I think I had tried to, but it didn't work, right? Let's see. So the Jamboards, if you will go to the classroom, which I think you can see now, in the course documents section, there's a thing that says Jamboards, AP Physics 1. And what I want you to do is just to use the Jamboard that corresponds to your breakout room. So if you're breakout room number 1, then just use AP Physics 1 Jamboard number 1. Okay, when you click on that, it should just take you to this blank document, and you can work on there. You can draw in there if you want to draw. You can add in images. You can type, whatever you want to do as you're trying to work through the questions. Okay, this allows me to see you guys working together and see how you approach the question and not just looking at the answers and things like that. Okay, questions about what I would like for you to do? All right, I am going to put you in 3 rooms, which will work perfectly since there's 12 of us. Sorry, 4 rooms since there's 12 of us. Your room should be open. You can go there. You can open up your Jamboard and you can start on example number 10. All right, guys, welcome back. I hope that that was at least partially a valuable exercise, digging through what you had seen last night in the video, trying it out for yourself, trying to figure out how to apply those ideas in a different scenario, recognizing that they don't have to give you very much information at all. In that one, you only had really 2 pieces of information given to you, and yet you were able to figure out a whole bunch of different things. The amount of time it would take to fall, the speed it's going to hit, the angle that it's going to hit, right? All these different things that you were able to figure out from that information, given the ability to pick out other pieces of information that maybe you had to pull out from an initial velocity, vertical velocity of 0, and the vertical acceleration, and the fact that the horizontal speed wasn't going to change, right? All those other things that you were able to add in. Okay. I just want to take a couple of minutes to talk about question number 11, because we're not going to have time to work through the whole thing. Lastly, introduce you to the College Board, the AP website, where you're going to find your practice questions for tonight. The question in number 11 is a question about volleyball. All right, and I've got I already drew up all the information here, right? They gave us that the ball was being launched at an angle. That's what makes this question a little bit harder. Okay, it doesn't actually make it that much harder. It just makes it a little bit harder that we have to deal with. All right, they give us a launch angle, they give us an initial speed, they give us the initial height, so we're starting at some initial height. They give us the height of the volleyball net here, and then they give us the length of the volleyball court, right? And so they ask us to find out, does the girl need to be ready to receive the ball, or can she just rest easy? So there's really 2 things that we need to look at. One thing that we need to look at is it going to make it over the net, right? If it's not going to make it over the net, it really doesn't matter. The second thing that we have to look at is, as the ball flies, is it going to land inbounds or out of bounds? And so there's 2 different points that we have to look at to determine, is this a feasible situation? Is the ball going to land inbounds or not? Okay. So in this scenario, what you have to do is you have to take this initial velocity here, the 15 meters a second, and you have to break it up into the horizontal and vertical so that you can treat this question exactly the same as we have the other questions. And so you're going to need to use your trig. This is why we learned about vectors before we did any of this. You're going to break it up into its initial velocity in the x direction and the initial velocity in the y direction, right? And so once you get it so that it's broken up into this horizontal and vertical velocity, then you can approach the problem just as you would any other problem, right? You can find out using the initial horizontal velocity, you can find out how long it takes to get to the net. And then you can use that time with the vertical information to find out, is it going to be high enough? Is it going to go over the net, right? If you wanted to, you could calculate the maximum height of the ball. The maximum height of the ball is going to happen when the vertical velocity is 0, right? Because it's going to go up, 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 and then it's going to come back down. It doesn't matter what the horizontal velocity is. All that matters is that the vertical velocity is 0 at that point, and you can identify that as a final point. So the main thing about this question, other than recognizing that we can take an initial vector and break it up into horizontal and vertical pieces, is recognizing that our final velocity, our final position, can be anywhere in our diagram. It can be at this point above the net. It can be at the point where we're at the maximum of the parabola. It can be the final point as it lands out of bounds, right? When my final displacement is negative 1.5. If I say that this is 0, if I say my initial displacement is 0 there, then my final displacement is negative 1.5 when it hits the ground. And so I can use that in conjunction with my kinematics, and I can find out how long it takes to get there. How long does vertically, that's vertical information, right? That's a vertical displacement from the beginning down to negative 1.5. Or I could say my initial displacement is 15 and it goes down to 0, right? So there are a lot of perspectives that you can look at, but you do have to separate out that horizontal and vertical. All right. So that's the big thing with these two-dimensional questions, is being able to separate it out and also being able to consider different points in the problem. Not just the beginning and end, but anywhere else in between could be my final position or my final velocity. Okay? Questions about that? Okay. I will try to put together a video for anybody that's interested in seeing that question be worked. I will mention a couple of things that I mentioned to one of the groups. On the AP exam, it is much more likely that you'll get a question like the horizontal one, where you're throwing it horizontally off a cliff, or possibly even where you're throwing it up vertically off of a cliff. Okay, those types of questions are more common. Okay, that's not to say that you can't get something like this, especially with the way that AP is going now. It's starting to become more likely because they are spending more time on questions. They're allowing questions to take a little bit longer because they want to see your reasoning skills. They want to see, if they give a situation where they're hitting the ball, can you think about, oh, well, it has to make it over the net and it has to land in bounds. Right? They want to see all of those reasoning skills come into place. It's called a transfer question, okay, where you're taking your physics and transferring it to a situation. They do want to be able to see that. And so this is not an impossible question. It's definitely one that they could bring up and ask you to do something similar to this, or shooting a cannonball over a wall, trying to hit the castle or something like that. I mean, those types of things can definitely come up. All right, so I will post a video for this for anybody that wants to see it, or if you just want to check the end of the video to make sure you got all the right answers, then that's fine too. But it's definitely worth taking time to work through. I do want to just show you real quick the College Board website. I had you guys do this the first day of class. If you go into the AP classroom for AP Physics 1, and I already signed in and all that kind of stuff because sometimes it does take a little while. If it's taking a little while, you know, if it's more than a minute, hit refresh, try it again. But it may take a minute just because there's so many students trying to access this, especially now. They have a whole bunch of videos and stuff up there. They've got a lot of stuff on the College Board website now. And so it may take a while to get it to actually load up. All right. So if you go here, you should see in Unit 1 there down at the bottom. I think this is where it shows up. I don't have the student one, so unfortunately I'm not 100% sure. But it should show up. There's a personal progress check. You'll notice that there's both multiple choice and free response, both of which are unlocked. That means that you have access to it, okay? The multiple choice, as soon as you answer and submit the final thing, it will give you the answers with explanations. Not only will it explain why the right answers are right, but it will also explain why the wrong answers are wrong. And so that's a really good resource conceptually and for multiple choice, okay? The free response is a little bit different. When you send in the free response, I actually have to accept it. I have to put in a score. If you send it in, I'm just gonna mark max score and everything and send it right back so that you can get the full write-up of the solution and what they're giving marks for, okay? So number one, that means you need to send it in. You can't wait until right before class thinking, oh, I'll have 10 minutes to check it, because you won't, because you need to send it to me and then I need to go through and click stuff and send it back to you. So first, send that in early. Secondly, the second thing is on that, when you see that you got a perfect score, that doesn't mean that you did everything perfectly, because I'm not doing that. I'm just making sure to click everything so that it gets sent back to you and you can get the full key, and then you can ask questions, of course, if you have it. Okay, but I'm just getting it back to you as quick as possible, not taking the time to dig through and look through. Okay. Awesome. Any questions? So I'm going to stop sharing that now. Oh, you'll notice there's a whole bunch of other videos there as well. And you can watch any of those if you just want some general review and things like that. You've got the general position, velocity, acceleration. You've got the representations of motion. So there's a lot of good things there that are available for you. Okay. We haven't done Unit 2 yet, so there shouldn't be anything in there. That's all forces and such. So. Questions?
Is Friday a good time to turn in the question to turn the questions in? Because before that, I want to review everything like the class notes and stuff, and then maybe on Friday I can do those problems.
Yes. If you send it in Friday, I may or may not get to it right away. But first thing, if I don't get to it Friday, first thing Saturday morning, I'll check it before my kids wake up. I'll get up and I'll check it and I'll get it sent back to you. So you'll at least have all day Saturday.
Are there time limits, and like, can you leave and then do it again like the next
You
day?
can leave. Yeah. On this thing, the personal progress, you can leave. You can go back to it. Yes, there's no time limits. I didn't set it with anything. What you need to recognize is that generally speaking, you get about 2 minutes per point. And so when we do a celebration, I will hold you to that. I'll give you a little bit of flexibility on the first one, just because it is our first AP celebration of knowledge. However, you need to recognize that if it takes you 5 minutes to answer that multiple choice question, you're probably doing it the long way. Okay, so I'm not going to set time limits, but you do need to be cognizant of that. Avery.
And how long would each free response question take? Should each
Same thing. It's 2 minutes per point. So if a free response question has 7 points, you should plan for around 14 minutes.
Thank you.
And most of the time, free response at the very beginning say this question is, 5 points. And so you know that you need that much time. I would always, at least if I were taking an AP exam, I would aim for a little less than 2 minutes per point, because inevitably you're going to come up with a question that you're going to need more than that on, either because it's a little more complex or because you don't remember something and you kind of have to dig through your brain for a little bit to figure it out. But yeah, I would plan for a little less than 2 minutes per point. Your celebration on Sunday will have both multiple choice and free response. Okay. And it will cover everything that we've done so far. So any of the kind of lab exploration, precision accuracy ideas, most of that will be in the free response section, so that you're able to kind of talk through it and say, well, this is good, this is bad, this is, how I agree with the way that experience, that type of thing. The linearization can be on there. That shows up in the free response from time to time. So yeah, anything that we've done up to this point is fair game. Lucia?
Will the format be the same as our last quiz that we had? Will we have a PDF and then you can either answer it on paper or write on the PDF itself?
This time, yes, it probably will be. I'm still playing with it as I build it, but I'm guessing that this first time it will be very, very similar, where you can either print it out, do it by hand, or just work it on paper and then send in images of your paper. Yeah. I think by next time I'm doing some exploring with College Board, and they actually have what they call a lockdown browser. And then with that, they allow you to use a larger number of actual AP questions. The number of AP questions we're allowed to use, like real AP questions, are fairly limited unless we use that. And so by the second test, by our second celebration in this class, we will hopefully be able to work within the lockdown browser, which means it'll be online. But for this first one, we're going to go with something a little more comfortable and just make sure that we can do it.
So, how many questions?
I'm not sure. With the amount of material that we have, I would guess probably around 30 points, which means it would be, about an hour of length. Again, I really have to play around with it a little bit and try to get a feel for it, but I would expect about an hour length. And of course, if it is 30 points and it's supposed to be an hour, I'll probably give you an hour and 10 minutes or something, just so you got a little bit of flexibility on this first one. I would say if there's 30 points, maybe 8 to 10 are, maybe 8 to 12 are multiple choice, and the rest are free response. I'd say from 25% to a third could be multiple choice-ish. And then the rest are free response. A lot of that experimental stuff we did at the beginning tends to be more in the free response section. So this one may be a little bit heavier free response. Like kinematics shows up a lot in the multiple choice. Just as a heads up, it's unlikely to be asked a direct vectors question, things like that. It's much more likely that it will be in context, like what we did today with the speed hitting the house, right? You had to find the velocity hitting the house, and that required you to use your vector knowledge. That's much more common for that type of thing. And same thing with the precision accuracy. You're not going to be asked for a definition. You're going to be asked to evaluate something, probably. Cool. All right. Well, if you guys have any other questions about the celebration or conceptually or whatever else, just send me an email and I'll do my best to answer. Or, all right, so this is question number 10 from class, right? We had the, this is example number 10 from your student notes. This is the airplane flying horizontally. The bananas are being dropped. The airplane's up at a height of 500 meters, and the student's trying to drop the bananas on me over here, smiling unassumingly, not having an idea about what's about to happen. So let's go ahead and look at the question and see if we can figure out how to solve it. What needs to be recognized when you have a question like this is that the bananas, as they fall, are going to fall in parabolic motion, right? So they're not going to go straight. They're going to start falling and falling and faster and faster and faster until finally it is as steep as it's going to get and it runs into my lovely home there. All right. So we have both vertical and horizontal motion going on here. And so it's going to be helpful to list both of those pieces of information, right? So we learned in class that when we were dealing with one-dimensional motion, that it was helpful to list out the information that we had, right? So we'd have the initial position, we had the final position, we had the initial velocity this will be in the x direction, right? I'm using x's here because this is talking about horizontal motion. One of the big ideas of the last couple of days is that the horizontal and vertical are independent of each other. They don't affect each other, right? And so we can separate those out in our problems. We can change this to the velocity of, that's the final horizontal velocity. We've got the acceleration and we've got time, right? So that's all horizontal stuff. Now, it's also going to be important in this question because we have vertical motion, likely to consider that as well. So I'm going to list all of my vertical information as well. So my initial y height, my final y displacement or position, my initial y velocity, my final y velocity, my acceleration in the y direction, and the time. Now, I probably should have put here acceleration in the x direction as well. All right. So now I'm going to go through and put in all the information I have, right? So I know for sure my horizontal velocity is 200 meters a second. Even if I drop the bananas out, it has that horizontal motion already. So that's the initial horizontal velocity is 200 meters per second, right? Now, horizontally, if we assume no air resistance, which is what we're going to do most of the time, at least if we're working problems all the time, is that we're going to assume that there's no air resistance. Now, if there's no air resistance, then the horizontal, there's nothing pushing or pulling horizontally, right? There's gravity, which is pulling up and down, well, just down, but it's pulling vertically, but there's nothing horizontally, right? And so we can go ahead and say that our final velocity is also 200 meters per second because our acceleration horizontally is 0 meters per second squared, right? So we've got all of those. We could also identify our initial horizontal position as being 0 meters because I'm starting here and moving in that direction. So I'm labeling this as 0, okay? I don't know how far I am, right? This right here is going to be that final x from there over to the house. I don't know that. And I don't know time. Now, it looks like I got a lot of information, but the problem here is the 0 of the acceleration, right? The 0 of the acceleration is essentially going to say, well, 0, so final velocity equals initial velocity. I know that, right? 0 final velocity squared equals initial velocity squared. Well, thanks a bunch, right? And then here, right, if I put 0 in for acceleration, 0 for the initial, oh, sorry, I do have initial velocity. I have 200, but I'm going to need the time or I won't be able to find the displacement. I got two variables there. So horizontally, I can't actually do much, even though I have a whole ton of information there. All right, so we're going to move over to the vertical, the vertical information. All right, let's see what we got. Okay, the initial y position. Now, you can either define this as 500 and this as being 0 down here at the bottom, or you can define this as being 0 and then this is negative 500. That's completely up to you. My brain likes for the ground to be 0. So I'm actually going to say that my initial height is 500 meters, and then my final height is when it hits the ground. This is just vertically, right? This isn't thinking about what happens horizontally. It's just, it starts up here and it ends down there. That's all that matters. The stuff in between doesn't matter at all, right? Sometimes projectiles go up and then they come back down. None of the stuff in between matters. All that matters is your initial position and your final position, all right? We've got the initial Y velocity. It's airplane's flying along, it's flying horizontally, so the initial vertical velocity is 0. It's not going up or down, it's just going horizontally, right? So that's going to be 0 meters per second. Now I don't have my final Y velocity, that's fine. The acceleration I know, right? That's negative 9.8 or negative 10. I think I'm getting the feeling that AP doesn't really care, but we'll go ahead and put negative 9.8 there, right? I put negative because it's down. I already defined down as being negative. I started at 500 and went down to 0. That was a negative displacement, right? So negative 9.8. Now with this stuff, I can definitely solve for time, right? I've got the initial position, the final position, the initial velocity. So I could actually go up here and use this equation right here, right? With the final position, the initial position, the initial velocity, acceleration. I got everything except for time. So I could solve that one right there. Okay, I'm not going to do it right now. That's your job. I'm just talking you through it. All right. So I could find time. Now time is great because the time is the same. The time it takes for it to get from up here to down there is the same amount of time it takes to get from here over to the house. Right? It's the same bananas, therefore time is the same in your vertical and horizontal as long as we're talking about the same point in time, the same location, okay? So once I have time, I can put that number over here, and now I've got enough information with time and speed and all these other things, I should be able to solve for position now, right? And that will solve letter A. Now, some of you say, yeah, but now I got to deal with the quadratic. I hate that one. All right, well, if you don't want to use the quadratic formula, or if you don't know how to use your calculator, well, number one, you better figure out how to use your calculator. Ask me, okay? You got to be able to use your calculator. But if you have your calculator, okay, once you know how to use your calculator, that's not a problem. But if you don't want to do that, then why don't you use one of the other ones, right? This we can't use because we don't have final velocity or the time. But I could use this. I could use this one and find the final velocity. And once I have the final velocity, I could use this to find the time, right? All vertically, only using the vertical information, right? Now, the second part of the question actually asks us to find the speed at which the bananas hit my house. Well, that speed, that velocity has two pieces to it. It has a vertical piece and it has a horizontal piece, okay? We know the horizontal piece, there's the final one, is 200 meters a second. So that's my horizontal piece right here. My triangle is obviously not to scale. The final vertical velocity is whatever I get here. And so you have to put those two together. Yes, they're vectors. It's why we learned about vectors, okay? And you're going to put those vectors together to get this final vector, right? In part B, all you need is the magnitude because the magnitude of the velocity is the instantaneous speed. So you should be able to find that speed as it hits the house. Then part C asks for the velocity, which means you also need a direction. Well, again, you already have the vectors drawn here. You should be able to get the angle. Okay, the best angle to get is actually that angle right there because that's from 0 down. And so you can just say it's negative whatever it is. I think it ends up being about negative 26, just so that you have a little check as you work through there. All right, so hopefully that was helpful in talking through this type of question. Break it up into the horizontal and vertical, and hopefully that'll help you. All right, Okay, that's it. I'm going to try to put together a separate video for example number 11 and talk you through that one as well. Okay.